In this video, we are considering the general gas equation. The general gas equation is a combination of Boyle's law and Charles' law. And of course, Boyle's law, at constant temperature, the volume of a given mass of gas is inversely proportional to its pressure, while Charles' law, at constant pressure, the volume of a given mass of gas is directly proportional to its temperature. It follows that the volume of a given mass of gas is directly proportional to its temperature and inversely proportional to its pressure. So V is directly proportional to T and inversely proportional to P. Therefore, V is equal to KT over P, and K is a constant of proportionality. So we see that PV over T is constant. So then we have it that P1 V1 over T1 is equal to P2 V2 over T2. This is the general gas equation, and it is a combination of Gauss' law, of Charles' law and Boyle's law. Now, from the above equation, when the volume is constant, then V1 is equal to V2, so that P1 over T1 will be equal to P2 over T2. This is known as the pressure-temperature law, or roughly just known as the pressure law. This shows that at constant volume, the temperature of a given mass of gas is directly proportional to its pressure. Therefore, an increase in temperature at a given volume or a constant volume for a given mass of gas would increase the gas pressure because the temperature increases. And this increase in temperature shows that there is an increase in the kinetic energy, in the average kinetic energy of the gas molecules present. This means that the gas molecules would move faster and collide faster with each other and with the walls of the container as the temperature increases. That is, the frequency of their collisions is increased. And that is the effect of increase in temperature. And as this collision rate increases, we now see that it will result to an increase in pressure. That is why increase in temperature directly increases pressure. Now let's consider some examples on this. A 330 cm cube nitrogen was maintained at 27 degrees Celsius and 9.0 times 10 raised to the power 4 Newton per meter squared. Determine its new volume on changing its temperature and pressure to standard temperature and pressure, STP. Now we use the general gas equation for this, and we have the first volume V1 as 330 dm cube, and P1 is 9.0 exponential 4 Newton per meter squared, and T1, that is the first temperature, is 27 plus 273 Kelvin, which is 300 Kelvin. Now, standard pressure in Newton per meter squared is 1.0 exponential 5, whereas standard temperature is 273 Kelvin, and we are looking for a second volume, the final volume. Using the equation P1 V1 over T1 is equal to P2 V2 over T2, and making V2 the subject of formula, we have it that P1 V1 T2 over, we have it that P1 V1 T2 over T1 P2 is the second volume, V2. And substituting for all the values there, we have the V2 to be 270 cm cube. And for the second example, what is the temperature of a given mass of gas initially at 0 degrees Celsius and 9 atmosphere if the pressure is reduced to 3 atmosphere at constant volume? And in the solution, we have it that the T1, of course, is 270 273 Kelvin, and P1 is 9 atmosphere, and P2 is 3 atmospheres, and we are looking for the second temperature, that is the final temperature. Using the formula, P1 over T1 is equal to P2 over T2. And making T2, that is the final temperature, the subject of formula, we have it that 273 times 3 over 9, giving us 91 Kelvin. That is the final temperature. Thank you very much. Ensure you watch out for our next video.